Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on DUIS. So this is our question. Starting from integration 0 to 1 x raised to n dx, solve integration 0 to 1 x raised to n log of x the whole raised to m dx. So we have to first solve this integration. We will find some answer to this. And by using that answer, we have to find this integration. So let's say this is our I. Integration of 0 to 1 x raised to n dx. What is integration of this? Integration of this is nothing but x raised to n plus 1 upon n plus 1, and here we apply the lower limit and upper limit. So this will be upper limit minus lower limit upon n plus 1. When we put x equal to 1, we get 1 raised to n plus 1, which will be 1. When we put x equal to 0, we get this term equal to 0. So we have integration of 0 to 1 x raised to n dx equal to 1 upon n plus 1. We have started this integration and we got this value. So consider this value. So we have integration 0 to 1 x raised to n dx equal to 1 upon n plus 1. Now we have to solve for this term by using this term. So what we are going to do, we have to find the value of this integration by using this. So how to find that? So let's say here we have constant n. So we will take DUIS with respect to n. So this will be integration 0 to 1, and now x is constant because we are taking derivative with respect to n. So whenever we have derivative of a raised to x is nothing but a raised to x log of a. Here the variable is x, but here the variable is n. So x raised to n log of x, derivative of x raised to n is x raised to n log of x dx equal to derivative of this term. Derivative of this term is nothing but minus 1 upon n plus 1 square. Now again we have to take the DUIS with respect to n. So we will get integration 0 to 1. Since we are taking DUIS again with respect to n, log x will remain constant. So we will have log x. And again we are taking derivative of this term. So derivative of this term is nothing but x raised to n log x. So log x into log x, it will become log x square dx, and we are taking derivative of this. So derivative of this will be minus 1, this minus 1 into minus 2 upon n plus 1 the whole cube. This is the first DUIS with respect to n. This is the second DUIS with respect to n. If we continue to take this DUIS, we will take DUIS with respect to m. Then we will have integration 0 to 1 x raised to n. Since here we have taken first DUIS, we get log x. We have second DUIS, we get log x square. When we take the mth DUIS, we will get log x the whole raised to m into dx. When we have taken first DUIS, here we got minus 1. When we took second DUIS, we get minus 1 into minus 2. So when we take mth DUIS, it will be minus 1 into minus 2 into minus 3 up to minus m upon. When we took first DUIS, we have n plus 1 the whole square. When we took second DUIS, we have n plus 1 the whole cube. When we take mth DUIS, we will have n plus 1 the whole raised to m plus 1. Why? Because in first we have 2, in second we have 3, so in mth we will have m plus 1. So this term will be, I am taking minus sign. So here we have 1 into 2 into 3 up to m. So we can write it as 1 into 2 into 3 up to m minus 1 the whole raised to m. If m is even, then this term will become even. If m is odd, this term will become negative. Let's say if our m was 3, so we will have minus 1 into minus 2 into minus 3. This value will be negative. If our m was 2, so this term will be minus 1 into minus 2. So this term will be positive. That's why we write minus 1 the whole raised to m and 1 into 2 into 3 up to m upon n plus 1 upon m plus 1. So we can write this term as minus 1 the whole raised to m. This is nothing but m factorial upon n plus 1 the whole raised to m plus 1. So this is the answer of this term. So this is how we solve the DUIS. More such modules we will see in our next video. So stay tuned for our future lectures.